Welcome to the next lecture on earthquake resistant design of structures. This is lecture 12 of the ongoing series. In the previous lecture, we had discussed about the masonry walls and we were discussing about various codal specifications as per IS 4326 for earthquake resistant design. So in this lecture, we would be talking about the wall openings. What are the codal provisions related to the wall openings? It comes to the light that in IS 4326, the dimensions of the wall openings are given. Moreover, their aspect ratio is also defined, as well as the level up to which the openings are to be given is also defined. Moreover, the corner dimensions of the openings, distances of the openings, corner distances of the openings, and the distances, inter-opening distances are also defined in this figure. Now, in the same code, in table 4, it's given that the distance B5 for from inside corner of the outside wall, minimum it's to be as per the building category. Now, building categories, we know D and E are the highest building categories for zone 5. It's building category E. Thereby, B5 will be 450 mm for such building categories. Now, for building category C, it's 230 mm, and for B, it's 0 mm. Now the total length of the openings, the ratio B1 plus B2 plus B3 plus B by L1, which is the length of the first wall, or B6 plus B7 by L2, which is the where L2 is the length of the second wall. There is a partition wall between these two walls. Now this shall not exceed, these ratios shall not exceed for one-story building. Now this depends upon the building category as well. For building category E, it keeps on decreasing from building category B to E, and for as with the story height, it also decreases. Thereby, for 3 or 4 story building in building category D and E, it's the minimum 0.33, and for 1 story building in building category B, it's the maximum 0.6. So one has to go on decreasing the amount of openings, the opening width, and moreover the opening area as we progress in zones, as well as there is an increase in the height of the building. Next is the pier width between consecutive openings B4. Now this has to be minimum as 340, 450 and 560 for building category B, C and D and E. Next, fourth one is the vertical distance between two openings, one above the other, that's H3. Now this has to be minimum 600 mm for B, 600 for C, 600 for D and E. So this is somewhat same in all the building categories, as the earthquakes do not normally act vertically, so this does not matter a lot. Width in the opening of the ventilator, B8, it has to be maximum 900 mm in all the building categories. 4-story buildings not allowed in category E, so one cannot go for more than 3-story buildings in building category E, which is meant for zone 5. Now there is one more interesting thing here which has not been shown clearly, is that the height above the windows or the doors. Now that also may be important, and it should be more than H3, that's the vertical distance between two openings on one of the other side. So what we come to know from here is that the openings cannot be provided at the corners of the building. They have to be provided at a certain distance from the corners. Moreover, they cannot be extended to the top of the building wall. It has to be kept from some distance from the top of the slab, such that there is an equal transfer of load from the slab onto the walls. Moreover, the thickness has to be maintained to the walls, which is T. If the opening of the wall is not provided, the is not strictly complying with IS 4326, and the building has already been built. Now the options that are left with us is the seismic strengthening. In seismic strengthening, what we do is that we provide a layer of concrete, reinforced concrete, around the opening. Now in this figure, one can see that the reinforcing bar is provided in the concrete. The concrete is thick T1 at the lintel level and T2 at the jamb level. Now it's also thick T2 along the sides, the vertical sides, besides which are the jambs, as well as at the sill level, which is at the bottom most. Now the concrete is cast into the brick by toothed elements, and the reinforcement is taken throughout the jamb and sill level of the opening, whereas it ends at a distance of 40D and 40D from the ends or corners of the opening at lintel level in the lintel band. Now in the lintel band, we already have a reinforcing bar running above this bar. Now the die of the reinforcing bar here is D, and the die of the vertical bar is V. Moreover, the thickness of the wall is T, as we observe from the section that has been cut. Now the reinforcing bars that are provided in the seismic strengthening of the walls and of the openings particularly that we are talking about is given here in table 7 from IS 4326. What we observe is that the maximum diameter here goes up to 20 mm, and in category E it goes up to 16, but there is no fourth story given in category E buildings. Now they are all high strength bars and they are deformable as well. The vertical bars that are provided and are to be provided in the concrete that is M20 grade, and we have to also see that these high strength deformable bars that are provided in the jambs and as well as in the lintel and the sill of the openings for seismic strengthening, they can be provided throughout the horizontal sill level as well as the vertical jamb level, and this is the minimum that has to be provided. Now about the strengthening arrangements. In strengthening arrangements, if we have openings in the masonry wall, what sort of strengthening arrangement shall we provide in this case of a masonry wall? We have already studied that we provide bands at plinth level and at roof level, but apart from this, the bands can be provided at various other levels. The bands are provided at lintel levels as well. Now this level is above the openings, wherein what we see is that there is a concrete band that's provided above the openings, be it doors or windows. Further to this, a roof or a floor band is provided at the top. A plinth band has not been shown here. There are doors, windows that are seen. Now they should strictly comply to the end requirements from the corners, and the distances between them should be maintained. Further, their level should end up, as discussed earlier, at the same level. At the corners, vertical bars are provided such as to make the corners much more stronger. This would lead to better joining action at the corners, and this would also lead to strengthening of the corners. Now, if the roof is pitched and not flat, then apart from the uh, other bands, a roof band or a eave level band is provided, as can be seen at 2. This is taken from IS 4326. Further, there is a gable band, as can be seen at 3. Now this band is provided in the masonry between the rafters of the roof and the masonry construction, which is provided in the triangular portion of the gable. Further, what we can also see is that the at 8, what we observe is that the roof has to be hold down into the wall. To do this, holding down bolt is provided at 8, as can be seen in the sectional view as well, and we can see that this hold bolt would certainly lead to a proper connection between the pitched roof and the masonry wall, such that they behave together. Now, in another diagram, what we see is that in the same diagram, what we see is that there is a roof band 2 which is provided below 7, that's the rafter. So this roof band, the whole bolt goes through the roof band. Now a door lintel is integrated with the roof band at 10, what we can observe in the third figure, wherein what we observe is that the lintel band could be continued up into the roof band of the topmost stories. So a perspective view is given here in A of the door lintel, and details of the truss connection with wall are given in B, and details of integrating door lintel with roof band are given at C. Some further details about the roof band. How is the roof band provided in the masonry structure? First of all, in the roof band, it should be made up of reinforced concrete, and that should not be leaner than M15, or reinforced brickwork, which is cast and cement mortar, not leaner than 1:3. The band should be provided over the full width of the wall. For example, if the wall is say 230 mm, it should be provided over the full width of 230 mm, and this thickness of the wall as well as the band should not be less than 75 mm in depth, and the reinforcement, and it should be well reinforced with steel. Now how it should be reinforced with steel, that's given in the table. In the table, what you can observe is that for building category B, one may come to know is that for span of the band being 5 meter or less, the number of bars has to be 2 with the die of 8, but with the span being around 8 meter, the die of the bars increased to 10 with same number of 2. Now in building category E, at the extreme end, what we come to know for zone 5 is that number of bars would be 2 with die of 10 for 5 meter or less span of the longitudinal reinforcing band, and it would be 4 number of bars with each having a die of 12 mm for span being 8 meter. Now the span of the wall will be the distance between central lines of its cross walls. For spans greater than 8 meter, it will be desirable to insert pilasters or buttresses to reduce the span, or special calculations shall be made to determine the strength of the wall and section of the band. This is given in note 1. Further, the number and diameter of the bars given above pertain to high strength deformed bars. If plain mild steel bars are used, keeping the same number, the following diameters may be used. High strength deformed bars 8 dia, corresponding to that mild steel bars would be 10 mm in dia. Now in the revised code of 4326, mild steel plain bars are not recommended for the design purposes in earthquake resistant design. So it's better not to provide mild steel plain bars. The width of the band is assumed same as the thickness of the wall. Wall thickness shall be 200 mm minimum. A clear cover of 20 mm from the face of the wall will be maintained. The vertical thickness of the RC band will be kept 75 mm minimum, where 2 longitudinal bars are specified, one on each face, and 150 mm where 4 bars are specified. Now the concrete mix will be M15, and the longitudinal steel bar shall be provided by steel link or stirrups, 6 mm dia, spaced at 150 mm apart. So apart from providing the longitudinal bars, we have to provide the steel link or the stirrups. These are just links which would be connecting all the steel bars that are provided along the thickness of the wall. So the idea is to provide the longitudinal bars along the running along the thickness of the wall and a link that would support them. Now these are the locations of the vertical reinforcement that's also provided at various locations. One of the vertical reinforcement, as we saw, was provided in the jambs of the openings. Further, the vertical reinforcement is also to be provided at the corners of the walls. Now if the wall is 1 brick thick in thickness, what is done is that the vertical reinforcement is provided as shown in A figure. Now one is the external and another is the internal partition, and both have different formations of vertical reinforcement. This is done such as to maintain the vertical joint between the brick walls, further to also give the strength to the corners of the walls. And in B, one can see is that when only the header courses are run along, header stretcher courses are run, then the vertical reinforcement in 1 brick thickness wall is provided in this fashion. Further, in C, for a 1.5 brick thickness wall, the vertical reinforcement is embedded deep into the wall joint, as can be seen at V location. Similarly at D, when the course patterns are changed in the brick wall. In E, one can see the interior wall, and F, again the interior wall with the stretcher courses running at the face and header courses at the interior face. So these are the formations of the vertical reinforcement. Now about the vertical reinforcement bar. The vertical reinforcement that's provided is similar to what's provided in the jambs of the openings, and there is no further change in the diameter of the vertical reinforcement. But what's to be ensured is that the vertical reinforcement has to be properly embedded in the plinth masonry of the foundation and of the roof slab or the roof band, such that it develops tensile strength in the bond. It shall pass through the lintel band and the floor slabs or the floor level bands in all the stories. The bars in different stories may be welded, and typical detailing of providing vertical steel in brickwork masonry with rectangular solid infills and corners and T-junctions have been shown already in the figure. What we have to observe is that the vertical reinforcement at the jambs of the openings is also provided in the similar fashion. It may also start from the foundational floor and it may terminate in the lintel band.